developers don't know jack about security. That's a really terrible thing to hear at a conference like this, right? Terrible thing to say. Developers don't know jack about security. That was actually a famous quote from a security conference back in 2011. A fellow by the name of John Willander, is he here? Heard he's floating around. A fellow by the name of John Willander was in the audience, and he had feedback for that security speaker. He said, I got news for you. You don't know jack about development. And this is true. This is kind of a disconnect that we've always had between the security people and the development people. And if we're trying to get developers to do security, we can't get them to do it our way. In the Middle East, we have a saying, if Muhammad won't come to the mountain will need to come to Muhammad. We need to bring the security mountain to our developer Muhammads. And that's what I'm going to be talking about now, value-driven threat modeling. All right, so who here knows what threat modeling is? Heard of threat modeling? Most of you, that's great. And for those not familiar, I'll give a quick run through of what I mean by threat modeling and how this affects. For those of you that are familiar with it, I hope to change your perspective a little bit on that. What's really important is that threat modeling is super important. We need to do this. This is the way to get secure systems. But we don't do it enough. And we'll talk about some of the reasons why we don't do it enough. Because we need developers to be doing it too. Statistics came out recently that for approximately for every 100 developers, there's only one security person. That's a whole lot of code being written that's not getting threat modeled anywhere near fast enough. Okay? Security people don't scale well enough. So we need the developers to be building the security into their systems themselves. As Jim Manico said, software engineers are security engineers, whether they like it or not, because they're the ones building the systems. And we need to get them to be doing it right. But if we want developers to be doing threat modeling, we need to change how we've been doing it. We can't be doing the same thing over and over again. We can't be doing it the same way because they don't work that way. They work differently. So if we want developers to be doing threat modeling, we need to offer them a different process that's a lot quicker. It's lightweight. It's agile. And we need to focus on business value. That's how we can make it quick and lightweight and agile. Because if we keep trying to force them to do it the same way that we've been doing it till now, we're not going to be better than this guy. We're not getting anywhere. We're just doing the same technique everywhere in every situation. That doesn't work. So, quick introduction about me. I was already introduced. I'll just give you that's my internet face over there. The important things you need to know about me, that if you ever want to buy me a drink, I like my whiskey smoky, I like my beer stout, I like my coffee black. I also have 5 kids at home, so kind of important, these drinks. The less important things about me, which you heard some of them already, I also do software security consulting at Bound Security, research, development, architecture. I am one of the leaders and former chairman of the OWASP Israel chapter. We have a fantastic conference over there, AppSecUSA. It was a month ago, so come by next year maybe. Free conference, it's fantastic. Some of the best researchers in the world are there, of course. I'm also the moderator on Security Stack Exchange. Who here has a profile on Security Stack Exchange? Wow, very few. It's basically the same thing as Stack Overflow, which I'm sure you've heard about, questions and answers, except in security topics. I have a bunch of stickers to give out, except that I left them on my desk back at home. So next time you're in Tel Aviv, come by and I'll give you some stickers. I also spent some time volunteering as a high school teacher, mentor kind of for cyber topics and prepare them for the field, which is great. We also have a threat model project in OWASP, which doesn't do very much right now, but it will eventually. So hopefully keep your ears tuned. So what is threat modeling? As most of you said, most of you are familiar with it. Those of you are not. It's kind of a structured methodology, approach, framework, whatever you want to call it. It's a way to do security-based analysis, to examine your design, examine your architecture, and understand where the security issues will be, and understand how your design could possibly break down. This helps you prioritize what you're going to fix, and also what you're not going to fix, because it's not that risky. It's not that important. So threat modeling is really important. Typically, threat modeling, we're talking about focusing on data flows, maybe using a data flow diagram, focusing on attack surface, how the attacker gets into the system, usually focus on what you're trying to protect, your assets, your database, your files, the cache in the system, whatever it is, focusing on what crosses trust boundaries. Visually is always good, it helps discuss. And the process is basically a 4-step process with a pre-step of deciding where our scope is, this is our system, and then step 1, you decompose the application, you take the design, the architecture, break it down to its components, you break it down to the different design elements. Based on that, there's different techniques to identify the threats and then you understand the risk level because you understand how it affects everything. Going forward, you can design, once you understand the threats and what you're going to fix, you can very clearly and easily decide how to fix it, the countermeasures, not always, but usually the easy part. And then there's step 4 of analyze it. Did we find all the threats? Did we find the right threats? Do we prioritize them correctly? Did we fix them correctly? And did we introduce any new threats? Not if anybody here has ever not seen a data flow diagram, it's very basic. You have the process, you have the database here, you have the flows moving around, the files over there, and of course the really interesting flow is the one coming from outside the system, from the user, crosses a trust boundary. Obviously that's the one we're going to model the first and the hardest, and then we're going to model the other components also. That's basically the way it works. Now there's a lot of different methodologies or approaches. Probably one of the most well-known is called STRIDE, or stride per element, sometimes known as the Microsoft model. Some people call it that. We'll talk about that in a moment. Different techniques called like attack trees, asset-focused, software-centric, attacker-focused. Risk-based threat modeling is a very interesting approach also. Talk about that. So STRIDE is basically a mnemonic. It's an acronym for spoofing, pretending to be somebody you're not; tampering, changing data you shouldn't have access to; repudiation, claiming you didn't do something that you did. For example, if the bank claims that you authorized a bank transfer and you say, hey, it wasn't me, give me my money back. That's repudiation. Information disclosure, getting access to data you shouldn't have access to. Denial of service, blocking a user from getting access to data they should have access to. And elevation of privileges, doing anything that you shouldn't be allowed to, like when you have teenagers at home. So this is very important. This is a mnemonic. It's kind of to kickstart your brainstorming, to understand what the attacker goals are. What is the attacker trying to achieve? Don't get hung up on categorization. Nobody cares what category it is. If you already found a threat, don't start arguing, is this a spoofing threat? Is it a tamper? It doesn't matter. It's just to feed your brainstorm. That's all. Now, it pretty much covers most attacker goals from a very technical level. You can argue about it. There's things to add, but it holds up very well over time. And then you could apply this STRIDE to the different components of the system, right? You ask the questions. For example, we could look at the flow between the user browser on the left to the web server right there, and there's a flow. And you ask, are there spoofing threats here? Can I pretend to be a user I'm not? Could I pretend to be a server that is not the correct server? Are there tampering threats here? Can I change the data? And you can go down the list and ask questions on STRIDE for each category through each of these elements. And then you could ask this on the back end also. For example, let's look at the middle, the flow between the application server to the messaging bus. And then you ask over there, are there spoofing threats? Can I pretend to be the application server and send fake messages to the messaging bus? Can I pretend to be the messaging bus and intercept valid messages from the application server so they never actually get there? Tampering, can I intercept those messages and change them? And so on. Can I access the messaging bus and remove messages? Can I change the ones that are there? And then you ask each of these STRIDE questions for each of these elements. That generates a whole lot of interesting threats that need to be mitigated or fixed or ignored. You can apply this also to other diagrams, whatever the developers are working with. A process diagram works the same thing, kind of a higher level, more of a logical view of the same thing, and apply STRIDE for each of these also. And then there's attack trees, which are another technique, which puts STRIDE a bit on the side, and we say, let's take this more of a logical perspective. What is the attacker actually trying to do? For example, the attacker wants to read another user's messages. Great. To be able to achieve that goal, there are a few different vectors, a few different attacks. It might be SQL injection. It might be bypassing authorization. It might be attacking the cache. And for each one of these vectors, there needs to be a corresponding countermeasure. And if there's any vectors that don't have the corresponding countermeasure in place, then, well, that's the point of doing the threat modeling, to find out, well, we need to deal with what happens if the user doesn't log off a shared computer over there on the left. So attack trees are very powerful, kind of a little bit heavyweight, but they're very powerful. Another very interesting methodology is PASTA. Stands for Process for Attack Simulation and Threat Analysis. The guy who wrote this, Tony UV, is from New York, so I think he's from New York. So yeah, PASTA, also right before lunch, so that's why it's called. But it's a risk-based methodology. It gives really, really good information, as pretty much as correct a threat model, as complete a threat model as you could possibly hope for. It takes those 4 steps that we talked about before, breaks it down to 7 stages, and there's a lot of statistics and data, and threat intel is in there, and you get really, really formal, good, a proper, perfect a threat model as you could possibly hope for. It gives really high assurance that the threats you're dealing with are the correct threats and dealing with it correctly. So really as good a threat model as you could hope for. This is fantastic for a security team. It's amazing for a chief security officer of an international bank, or it's fabulous for a chief risk officer of a Fortune 500. You know what it's not so good for? These methodologies don't work well for developers for various reasons. We're going to talk about that. Let's take a look at what a developer thinks about all these methodologies, whether we're talking about Adam Shostak's stride per element or pasta or whatever it is. You go down the list and you get developers to do threat modeling, or we do threat modeling with the developers, and you're going to get pretty much consistently some of these responses. You go off to the security team and you wait for 3 weeks until you get an answer, or you send it off to an external consulting company, come back 2 months later. Come on, we're dealing with 2 week sprints here. Come on. Security is everybody's job. I'm sure everybody's heard that, except I'm a developer. My job is not security. My job is to write code, to put out features, to add value to the business. Sure, security is my responsibility. I have to take care of security and performance and usability and a whole bunch of other things, but my job is to write code. These poor developers, they have 8 bosses. 8 bosses now, Bob. Do you really want to be number 9? Think like an attacker is particularly insidious because it sounds good, but it doesn't really add any kind of guidance. It doesn't give you any information of, I'm a developer. What does that mean, think like an attacker? As Adam Shostak says, quick, everybody think like a chef. Does that help you bake a better cake? Does that mean all of a sudden I could make soup? Think like an attacker? That's not really very helpful. Why bother threat modeling? We know what they want to do. We're a banking system. They want to steal money. Of course they want to steal money. There's nothing else to talk about. Why are you modeling this? Let's get into really how developers work. Threat model needs a lot of details, a detailed spec, right? Use case, kind of waterfall-y. Developers don't work that way anymore. Lightweight, user story, invitation to a conversation, keep going. And very similarly, at a higher level, Agile says no big design up front, right? Well, if you don't have no big design up front, how are you going to do a big model up front? You're trying to squeeze yourself into a place that you can't do. No big design, no big model. Now, threat modeling is really great. You get all the security design in one place. All the security documentation, why you made these choices, what threats you're dealing with, how you're dealing with them. That's fantastic. But then when you go and deal with the actual functional design, there's barely any security information there. If you're reading the design and why it was constructed this way and how you're doing this, there's no security information there. The threat model is separate. And partially because of that, and also for other reasons, by the time the threat model comes back, well, we already removed that feature, it's fine. Or, we decided 3 weeks ago to change the implementation, so your threat model is not really relevant. So thanks for that, but we appreciate it. You get back through the threat model, a whole long list of threats, and what? What am I supposed to do with that? It's not in my Jira. It's not in my backlog. What do you want me to do about that? A great thing about threat modeling is that you don't waste time fixing things that are not really important. But you do waste time modeling them. You do waste time threat modeling issues that don't really have any relevance to me. It's great that we're not implementing fixes to them, but come on. Now, developers are stallions. They run forward. They want to sprint. They want to build things. And if we were making them wait for the security team to get back and tell them how to build it, well, security people like to tear things apart, right? Kind of a mismatch. Doesn't really work. Every 3 weeks, security team comes in and says, everybody stop! What you been doing? What's going on? Tell me everything roll back. Explain it to me from the beginning. I was like, come on, I don't remember what I ate for breakfast. Do you think I remember what I did 3 weeks ago? And partly this is because, as I mentioned before, for every 100 developers, there's 1 security people. Security teams like to pretend that we have these big drone armies, but it's simply not true. There's simply not enough of us to go around. So again, if we want threat modeling to be done, we need developers to do it. Because if we say you have to do this, what the natural response is, okay, sure, we'll take care of that. We'll get right on that as soon as we're done with our backlog. Sure. And so we as a security team are stuck with our shovels in our hand, paddling upstream, and it's not really getting anywhere. We keep trying to pitch Hail Marys, and we're not moving the needle. We're not advancing yard by yard down to the touchline. And we're just spending a lot of effort and not getting anywhere. We're not using the right tools. It's not the right tool, and we're just not getting anywhere pursuant to the amount of effort we're putting into this. So what I'm saying is we need a little bit different. Let's take threat modeling and pretend it's something slightly different. So Adam Shostak, which is basically the father of modern threat modeling, basically says all the different methodologies that we use for threat modeling are coming to answer 4 basic questions. Number 1, what are you building? This is the system, the design, the application design, application decomposition. Number 2, what can go wrong? These are the threats. What are you going to do about it? The countermeasures. And did we do a good job? Did we find all the threats? Did we introduce any new threats? Did we fix them properly? And so on. Adam Shostak also says something else. I like to misquote Adam, and he doesn't say, all threat models are wrong, some are useful. So if there's one thing you take away from my talk, make it be this. All threat models are wrong, some are useful. And yet, all the different methodologies we're talking about are trying to make these as correct as possible. But all threat models are wrong. You can't make a correct model, because all models are wrong. All threat models are wrong, some are useful. Great! Make it as wrong as possible. Lean into it. Grab the wrongness with both hands and focus on the usefulness. Focus on what value this adds to the features that you're developing. So I'm going to take these 4 questions and slightly rephrase them. Slight rephrasing. Number 1, why are we building this? Okay. What is the reason we're building this user story and not that other feature over there? Why did product management decide this feature gets built? What value does this add to the system? Is it adding new users? Is it adding more revenue? Why are we building this? Developers already know what they're building. You don't need to discuss that with them. You don't need to go over the application design all over again. They know that. But why are we building this? What value does this add? Number 2, what needs to happen? What needs to go right to make sure that we achieve that value? This feature we're building, it can go wrong. It could go right. What needs to happen to make it go right? What happens to make it work? And how do we ensure that those conditions that I just stated to make the value, to achieve that value, how do I ensure that that actually happens? Now, it's basically the same 4 questions, slightly rephrased, pivoted around a very, very important concept. Now, before I introduce this concept, I need to give you a bit of warning. It is a little bit shocking, especially to experienced security people. Leave your snark at home. We don't need that. Don't pack up your FUD. There's people here. We know everything's broken. Have you seen the internet? We're still building things anyway. We don't care. We're going to do it. This is what developers do. Developers are a lot more upbeat. We build things. We're going to do it anyway. We don't care that it's built on a house, on sand. It's fine. Recently, I saw an argument on Twitter just a couple months ago that called out a very important point. In the aviation field, they don't talk about preventing accidents or blocking hacks. They talk about safe transportation, achieving value safely. This is where we need to be focused on. Not blocking hacks, but building features, adding value to the business in a way that does not add risk. Because at the end of the day, we want developers to be doing this. We need to give them the correct incentives because they're going to be working the way they work anyway. So we need to make sure that the way they work gets to where we want to go. We need to give them the right incentives for that. Why are we building this? What is the value behind it? All right, so I talked a lot about what was wrong. Let's talk about how to actually implement this. So number 1, we need focus. We don't need to waste time on things that we know about. Okay? We don't need, start from a basic architecture. That's fine. As we go and develop, most of the development going on is for adding new features. That's just the natural way it is. So we start from a baseline, and we don't waste time modeling things that we already know about. The basic OWASP top 10. You don't need to go away for 3 weeks and come back to like, oh yeah, you need to worry about XSS. Or wait for the consultants to come back 2 months later. Make sure you put SSL on those endpoints. Like, duh, that's basic code hygiene. We know these things. Most developers should know these things. And if they don't, that's where security training comes in. Okay? Using the threat library, a lot of products are out there. There's some threat libraries coming out. OWASP is working on some of that also. It's a good template to be able to just start with. You have a website. You obviously need SSL. You need to worry about XSS, SQL injection. So you don't need to waste time doing a threat model for all these things. Now, where are we doing the threat model? On each user story, or epic, or feature, or however you're working. Wherever you're building that design, that's where you do the threat model. Because threat model is kind of part of the design. So as you're doing discovery for this user story, or during the sprint planning, or however you're working, and you're discussing what we're building, that's when you do the threat model. Agile likes talking about just enough design. Well, I'm talking about just enough threat model. Remember, all threat models are wrong. This is not a complete threat model. It's useful. Okay? And this threat model is part of the definition of the user story, part of the design of it, and that's something separate. So you're not going to be able to get a threat model document because it's part of the user story. So for each feature that we're building, right, for each feature or user story, we go and we find the value. Usually, you follow the money. Usually, it's adding users, adding sales. Follow the money. Sometimes, how do people die? You're building aviation systems. You're building hospital control systems. So you find the value. Why are we building this feature? Find the value. Follow the money. How do people die? And how do we actually do this? Well, number one, during the discussion of what the user story is, what we're building, what's the goals? What are we trying to achieve here? Okay. Number two, what actually needs to happen? Now, this is something that developers typically do anyway. Some of it is a little bit implicit. Just be explicit about it. What needs to happen, what shouldn't happen, failure states. What happens what's supposed to happen when things go wrong. Assumptions and conditions. These are very usually implicit. That's the point of assumptions, right? You know what they say about when you assume, you make a fool out of yourself. So if you're explicit about your assumptions of how the correct flow works and the conditions for this to happen, then you can go ahead and validate those assumptions and enforce the conditions. That's basically the countermeasures that we're talking about. That's basically what we need. And you handle the failure states. You explicitly handle when things go wrong. And that's basically the whole process. Very simple. That's a process, that's a workflow that we can get developers to do as they design and build each user story. Is this a complete threat model? No, of course not. That's fine. All threat models are wrong. Focus on the usefulness. I'll give you a quick example, taking the OWASP juice shop. That's about as much architecture as that we need for at this point to understand how it works. Those of you not familiar with OWASP juice shop, it's basically the best place to not buy juice on the internet. A broken web application by OWASP to show how to do it, how to build things and test vulnerabilities with modern technologies. And you go, you buy your monkey juice. And one little feature that I'm going to talk about right now, as you go to checkout, there's a little button to put in a coupon to get a discount. They publicize the coupon on Twitter. And for the next 30 days, you get 30% off. And you plug that in. Now you could just go and try and fuzz that. Big deal. It's obviously it's code. Let's try and fuzz it or decrypt it or whatever. Or you could try and threat model that to a large extent. But I'm going to ask you this. Why do we have this coupon feature at all? What is the purpose? Anybody? Cheaper juice is not the point. That's not why we're building the feature. We could just lower prices. We want new customers. Marketing came out with some studies. We'll probably have a 20% uptick, and half of that will probably stay residual customers. Right? They're going to come back. Give them 30% off, and we'll get a 10% increase in returning customers. That's the point. So if that's the point, now we could start asking questions around that value. Okay, so 30%, can I make that 60%? Can I make it 90%, 200%? But let's go the other way. Can I make that code cost more? So not only am I not gaining 10% of customers, I'm going to be losing customers because you just doubled my prices. Focus on where that value is, and you can countermeasure around that. Let me just give you some real quick ideas, techniques around this value-driven idea. Okay? Some of the things, number one is definition of done. Agile defines that for each user story, before you can consider it done, you need to, it's kind of procedural requirements. Okay, it needs to be coded and tested and user tested and so on. And we're going to throw in, as an example, definition of done. You're not done with your user story until there's a threat model, as we just defined, in place in that user story. So you're not done. And we're going to require you to build security tests, just as an example. Definition of done. Then there's acceptance criteria. As you define each user story, you define how to verify that this user story is built correctly. Acceptance criteria. For example, when I log into the juice shop with a password, I should be locked out after X number of times. Acceptance criteria built into the login story. That's very simple. It's very straightforward. And then we can define user security unit tests around those acceptance criteria. Very straightforward. Around that exact acceptance criteria, we're going to build we're building unit tests anyway. So turning this security requirement into a functional requirement, test that accounts are locked out after X attempts, and the corollary, of course, that they're unlocked after Y amount of time. That's great. Nothing new here. Abuser stories. Abuser stories are basically the same thing as a user story, but from the perspective of the attacker. Now, there's a lot of arguments. A lot of experienced people don't like abuser stories for the simple reason that it comes back to think like an attacker. How could I possibly know what the abuser is trying to do? Why do I care about what he does? But it actually is rather useful when you pull the abuser story back into your own value story. Okay? As an attacker, I want to impersonate another user so that I can steal their juice box. That's my value. Juice box, that's what I sell. That's where I get my value from selling juice. If somebody's stealing somebody else's juice, that affects my value. That affects my bottom line. A few months ago at the Open Security Summit in London, we were talking about this, and we said, everybody's familiar with the agile user story structure, right? As a I want so that Somebody said, well, what if we put security right into that? So after a discussion, we came up with this idea without. Just one additional little clause. As a customer, I want to complete a purchase of juice so that my juice arrives in the morning when I need it, without my credit card being stolen. Now there's almost zero level of detail there. But that's true about the whole user story format. As a customer, I want to complete a purchase. There's no detail on that. A user story is an invitation to a conversation. We're going to flesh out that details as we go. We're going to have all that information when we need to build it. But we're sticking a flag in that. We're sticking a pin and saying, without my credit card being stolen. So now we have to actually discuss that too as we're elaborating on what this user story is. Again, no detail. That's going to come out afterwards. We're plugging that right into the way developers and agile product owners develop their user stories. As a I want so that without my credit card being stolen. I like to talk about threat pyramids. Everybody's familiar with the old food pyramid, which has been debunked. But you need a certain amount of grains, a certain amount of fruit, a certain amount of vegetables to be healthy, but not too much, because that's unhealthy, right? I'm sure everybody's familiar with Maslow's hierarchy of needs. There's no point talking about esteem and things like that until your safety and physiological needs are met. In the same way we can apply this here, there's no point of talking about denial of service while you still have remote code execution going on. But you don't want to get hung up on just remote code execution, so you need a certain amount of testing for RCE, and only when you're reasonably sure that you don't have any RCE issues and remote code execution issues in your system, then you can start going up the stack. Make sure there's no data tampering issues. Eventually you get to data denial of service issues. Of course, what usually happens, we spend half our time on dealing with SQL injection XSS, some time enforcing weak passwords, and throw the rest into spam and antivirus, which is not very useful. But we could turn this around and take this more to my business value. What's the most valuable thing in my system? Usually it's a bank account. That's where the money is, right? And when we're reasonably sure that access to my bank account is protected, then I can go up the stack and start worrying about credit cards and PII. Again, this is where money is, right? You get fines, that's substantial. Only reasonably sure about that, again, we can go further up the stack, start protecting our market share, stolen juice, and things like that, where our value is. Now, another very interesting thing came up when I was discussing story points with somebody, and I blamed the fact that I was an artillery and I don't hear well, so somebody said story points. I said, story points? What's that? That sounds really interesting. Tell me more about story points. Well, story points is actually a really interesting thing. Story points is a very rough, inaccurate measure relative how much work is this story compared to that other story to implement. Story points is how bad would it be if this story explodes in my face, if this story goes wrong. How bad would it be relative to that other story? Maybe they use Fibonacci sizes or shirt sizes. Not a lot of details, very rough. But how bad would this be if everything goes left and blows up in my face? Are we talking about a few hours of overtime, or I get stuck stranded on a beach with a couple of pythons while a shark-eating dingo looks on? How bad would it be? Now, this is very important because this knows we want developers to do it themselves, but we need to give them a tool for escalation. Maybe they could do it themselves. Maybe they could do it themselves, but they need to spend more time on it, or call a buddy in to help out. Or maybe we need to escalate to the security team, or call in Adam or Tony to come do a full-size proper threat model. So this is a tool for escalation of how bad would it possibly be if I get it wrong. Now, value-driven also gives us other tools. It helps you communicate these issues and bugs a lot better. Now, you could talk about cross-site request forgery, and you explain, put out, do a pen test or a code review and give out a report or threat model, explain what cross-site request forgery, and everybody's like, oh, that's really interesting. And then they get to the real important issues. What do you think they're serving for pie at lunch today? Because nobody really cares about these things. But if you then translate it as something that affects the business value, unauthenticated access to cash transfer, which is basically the same thing that's enabled by CSRF, all of a sudden that gets attention. That's interesting. You talk about stored success. Oh, that violates our code security policy. That needs to be fixed. Fine. 3 years later, you come back, it's still there. But if you say, I can take over an administrator account, that's going to get fixed. For the same thing, I can bypass authorization controls, but I could also change where you're delivering your juice boxes. All of a sudden, you know what? That's going to get some attention from the board, and they're going to make sure that gets fixed. Denial of service, translate to the loss of revenue, and so on. How does this affect the business value, the bottom line? This also helps when you're doing pen tests. I was discussing yesterday in the WIA pen test training of how to apply threat modeling when you know nothing about the internals of the system. Just translating it to business value. Now, benefits is very clear. It's a lot quicker. You get to useful faster. It goes the way the developers do it, the same process. It's iterative. The retrospective is built into the agile workflow. It's natural. It's part of the documentation. It's always there. It helps you communicate a lot better. It integrates with existing agile processes because we're using their tools. Most importantly, you don't need to pay people like me a ton of money or people like Adam a ton of money to come in and do threat modeling for you because you're doing it yourself until you really need it. And of course, it is scalable because we're counting on the developers to threat model what they're building instead of one person fighting against 100 developers. I told you what's good about it. Let's talk about what's not good about it. It's not a complete threat model by any stretch of the imagination. You're missing a lot of the threats, missing a lot of the detail that you get through threat intel and in-depth threat modeling. You're hoping the developers know what they're doing because you're not calling in the expert each time, which is kind of the point, but you're kind of optimistic that they're actually doing it right. It's really useful to have a security champion in the team to help you out with this. If not, we'll figure it out, but more importantly, it does not give high assurance like some of the other methodologies, the other approaches. Which is fine. If you're building a banking system that protects billions and trillions of dollars in assets, this is probably not enough for you. If you're building a system for the DoD, you're going to need a bit more rigor in your threat modeling process. It's a good place to start. You'll need to get somewhere else, but it's not complete threat model. But that's kind of built in, because the point is we need developers to start doing the threat modeling. They're going to get it wrong, and that's fine. But it's part of their workflow. The first time they do it, it'll be completely wrong. Won't even be useful. Second time, it'll even be useful. The third time, now we're getting somewhere. It's still going to be wrong, but that's OK. All threat models are wrong. And this is, if you take one thing away from my talk today, it should be this. Not the other one. This is the most important one. Developers need to be doing the threat modeling. How? By focusing on the business value, which is what they deal with. They don't know all the kinds of attacks and threats. They're not up to date on that. They can focus on enforcing that the business value that they're building is achieved. You focus on the useful part, and only escalate when you need to. Probably don't need to. That's the story points comes in. If you need to escalate, you can. If you don't need to, stop. Thanks very much. I hope this is useful for you.